Okay. In this talk, we're going to discuss the famous theater show Who's Afraid of Virginia Woolf? If you've seen it. If you haven't, you should. It's very good. No, we're not going to discuss that. We're just going to discuss Monty Python. The Big Bad 3. Because who wants Python 3 anyway? Python 2 is good enough. You'll have to spend hundreds of man-hours, and there's no third-party modules, and Python 3 was just a mistake because no other language ever breaks backwards compatibility, and everything breaks in Python 3. It's really a new language, and the core developers aren't listening to us. Or is that how it is? Well, obviously the core programmers do listen. They also have spent a lot of time writing FAQs and guidelines, as well as tools to help you to transition to Python 3 smoothly. And they also listen to the claims that Python 3 was a mistake, but they disagree. And if it was a new language, you would get confused when you're reading the code. Like if I'm reading Ruby code, I will understand most of it, but I'm not a Ruby programmer, so there's things that I don't understand. And that's not the case with Python 3, I promise. I mean, you might be able to get a bit confused if you don't know about the function annotations, and you have function annotations, because that's a new feature, but then again, you can kind of ignore it. And most people don't use the function annotations. And even if Python 3 wouldn't have happened, then we would still have function annotations. They would just be in Python 2, right? And not all code breaks, but all non-trivial packages will break. That doesn't mean that it's hard to fix it. And this really boils down to what backwards compatible means, right? I saw Armin Ronacher, who complains a lot about Python 3 for good reasons, compiling early versions of Python because he was preparing a big blog post about what he actually wanted Python to be. And so he found the earliest version of Python he could find and compiled it, and it actually had to change the C code just a little bit, but still, and it would still then crash on exit every time, but otherwise it would work. And then you come to the question of what does backwards compatible mean? Well, it doesn't mean that your code is going to run forever without modifications. You will have had to change your Python code before. If you wrote Python for Python 2.1, and you switch it forward, you will have there's new keywords, and that means you're going to have to change your code because your variables have now become keywords. So what backwards compatible means is rather that you can, when you change the code, it will still run on the old version. And that can be true for Python 3 and Python 2 as well, depending on how you write the code. However, you might have to introduce situations where you check if it is Python 3 or Python 2, and then you have to have different code. And then you can say that, okay, fine, it's not backwards compatible, because you have to actually check which version you're running. So this thing that is backwards incompatible is not as a big issue as some people try to make it into. But yes, changes as big as between Python 2 and Python 3 are unusual, maybe unheard of in programming languages. Could it then have been backwards compatible? And no, because there were several mistakes in Python 2 that you could not fix in a backwards compatible way. Things like how Unicode was handled, and another simple example is that you can in Python 2 compare strings and numbers, and those comparisons make no real logical sense. Now the only way to fix that is to stop being able to compare strings and numbers, and that's a backwards incompatible change. So they wanted to fix these things that could not be fixed in a backwards compatible way, and then they decided to fix all the other things that was already fixed. For example, or clean up those things rather. Like range turned out to be a mistake. It returns a list. So xrange was introduced. But this means that you now have to teach people what range is, and then you have to teach them that they shouldn't use range. And this introduces extra complexity when you're teaching people Python. And Python has now, because it is simple and because it fits your brain, become one of the most, in some cases, some people claim that it's now the most popular first language that people teach in universities. And we want it to continue to be the most popular language, and we want it to continue to fit your brain. And that means that when we add new features like function annotations and, you know, even the things that's been around for a while now, like generators, it also needs to be cleaned up. And I shouldn't say we all the time because I'm not doing that. Oh, Lukas is. Yeah. But we want Python to be clean, so we want Python 3. So I don't think it was a mistake. And there are third-party modules. There's 4,000 third-party modules when I checked a couple of weeks ago. Of the 200 top packages, 165 support Python 3. The 35 that does not, or this is also a couple of weeks ago, it could have changed. The 35 that does not all of them are actually libraries. So some of them are applications, which means that they don't really need to support Python 3 because you don't need to import them from Python 3 ever. 3 of them at least are deprecated and have replacements. One of them is paste, which I'm going to mention later. So the situation is pretty good actually. And who wants Python 3? Well, you do. One thing I didn't actually mention in this list of things that I'm going to take up now is function annotations. And that's because even though it's cool, maybe it has a specific limited usage. Not everybody wants to use it all the time. But here are things that you probably want to use, or rather, and in the situation where they're useful, you definitely want to use them. Python 2 has iterable unpacking. It's called, you can write ABC equals and something that is a tuple of 3 items or a list of 3 items, whatever that's actually iterable that has 3 items, and you can write ABC equals something. In Python 3, you can pick out a couple of the first and a couple of the last, and then you can have this star rest bit in the middle, if you can see it in the back. That will then take all of the rest of the items in the iterable. So this looks a little bit like how you define args in function definitions, right? It's another good example of how Python fits your brain, because this looks like it's first 2 positional parameters and then it's an args, and then it's kind of a keyword parameter, although you don't give a keyword to it in the end. But it looks similar, and you can think about it in similar ways. And in a parallel to that, of course, they've introduced something like this in function definitions, that you can now put in things, you can put in an argument after the args. And the end result of that is that you have to pass it in with a keyword. It's basically a required keyword parameter. So it's a keyword parameter that does not have a default. And that is highly useful, but quite often you do want to have keyword parameters that are required. For example, when you're in a situation that you have a keyword parameter and it has a default, and then you figure out that actually using that default was a bad idea, and then you don't want to change your API so that everybody has to rewrite their function calls, and then you can use this. In Python 2, if you raise an exception during an exception handling, the first exception gets lost. In Python 3, they get chained, so you get both tracebacks. This is very handy when you get error messages from your customers. You can also, like I do here, chain them explicitly, so you can raise one error from another error. Although that's more use more unusual, of course. You also have better exceptions. The OS error exceptions have lots of errors behind them. And if you want to handle different errors differently, you have to actually look at the error message. So you have to catch OS error, then check which error was it, and go, oh, I don't care, I'm not handling this error, and then you have to re-raise it. In Python 3.3 and 3.4, each of these error numbers have their own exception. You can also, with a command line parameter to the Python interpreter, get a warning if you don't close files. Of course, files will still be closed when the file object is garbage collected. But now you can get a warning when that happens, because you don't actually want that to happen. You want to close the file as soon as possible for various reasons. Can even be security problems. And you might think that this is kind of useless because you have to pass in a command line parameter for it to happen, but unit tests tend to turn it off. The test runners turn this on, so you usually get these errors when you're running the tests, which is very good. You can also delegate your generators to subgenerator with yield from. Very handy if you use a lot of generators. I like generators. Super doesn't need the class name and self anymore. So things like this. This is what you want. Why you want to move to Python 3. The last thing is asyncio. There's a lot of new modules in Python 3, especially later Python 3 and Python 3.4. Most of them have backports, so you can use them in Python 2.7 anyway. But asyncio does not. It requires Python 3.3 or later, and it's, if you don't know what it is, it's kind of like Twisted or G-Event or Tornado, but it uses generators. And it's the new cool thing. It seems pretty nice, actually. And how much time do you have to spend on these? Well, hundreds of man-hours were probably true in 2009, when there were very few third-party modules that supported Python 3, and when you probably also needed to support Python 2.5 still and Python 3.1. But today you don't need to support those. You only need to support Python 2.6 and Python 3.3 typically. Hopefully, you could say even. You only need to support those as the minimum versions. And then it becomes much simpler because there's more backwards and forwards compatibility. So it's not so bad today. And this is why I'm trying to, and I'm sure I'm going to make this mistake several times during this talk. I'm trying to not say port about moving to Python 3. Because it's not really a question of porting anymore, because the differences aren't that bad, it's not that difficult. I'm trying to talk about supporting Python 3 instead. But I still make the mistake, I still call it porting. Many changes, of course, are handled by 2.3. This has always been the case. But today, since you don't need to support Python 2.7 anymore, more of these changes are also supported by Python 2. And some changes you don't have to do anything about. Dict.keys no longer returns a list, but that doesn't matter, does it? Because you don't use it as a list, because if you do, you're going to get weird problems, because the ordering of dictionary keys is arbitrary. So you can't rely on your dictionary to have a specific order. And therefore you can't use dict.keys as a list because you don't know which item you're getting from it. And indentation is stricter, but you're not mixing tabs and spaces anyway. So this is not a problem. And Python 2.6 and 2.7 has forward compatibility, as mentioned, with things like this, future division, and the new exception syntax is supported in Python 2.6, both the new and the old, things like that. And Python 3.3 brings back the Unicode literal. Because it was figured out that you actually need to talk about 3 different types of strings when you're talking about Python 2 and Python 3. You have the bytes strings, or the 8-bit character strings, and you have Unicode strings, and you have native strings. And native strings are the thing that is just called str. That means that under Python 2, a native string is an 8-bit byte string, but on Python 3 it's Unicode. And you need to talk about this because some APIs will expect native strings. So in some cases you need to use native strings in both versions, and in some cases you need to use byte strings in both versions, and in some cases you need to use Unicode strings in both versions. So once this was realized that we actually needed some way to differentiate between these 3 types of strings, the Unicode literal was brought back. And Guido refuses to lend me his time machine. Otherwise, I would have known this in 2007 when I argued for the Unicode literal to be there. And I got a lot of good arguments why it shouldn't be there. And I said, well, okay then. I said, well, from future import Unicode literals, that's going to be good enough. Oh, okay. It wasn't. So that's my fault that this wasn't in Python 3 from the beginning. So what is hard then? Well, the first thing, and you really don't want this to happen to you, is if your API changes. Because the API sometimes has to change when you move to Python 3. I have 2 examples. The first is SOAP interface. And you see here that it declares the interface, which interface this component implements, with this syntax here. And that's a function. And that function is run during the class definition, right? So how does this work? Well, this function will insert a meta class statement into the class definition. And this will then mean that when the class is created, at the end of the class definition, it will use a meta class. But in Python 3, the meta class is not defined in the class body, so this doesn't work. You can't use this. Therefore, I have to move to this syntax. You have to use class decorators, because class decorators showed up in Python 2.6, I think. And when it was time to move this to Python 3, this class decorator already existed, so at least we didn't have to write that, because then it was there. But we did have to write a fixer. And a fixer is a little piece of code that will refactor Python code. And it's used by the 2-3 scripts and the 2-3 library, lib2-3, to change from Python 2 code to Python 3 code. Lib2-3 is actually a generic Python code refactoring tool, so you can use it for any sort of refactoring. It's pretty cool, but it's badly documented, unfortunately, and that makes it hard to write fixers. But so I wrote fixers for this and tried to avoid to write fixers. It can be fun, but it can be also very frustrating. The second example, we can't even use a fixer to change the API. So the API has to actually just be changed, and all the users of the API or the module has to be told that you have to change how you use it. iCalendar has iCalendar objects. They're object-oriented representations of iCalendar data. iCalendar data is data used by calendaring applications to exchange information about events. iCalendar data are UTF-encoded strings. So they are 8-bit strings because they are encoded in UTF. Remember that UTF is not Unicode. UTF is binary data. And this works fine under Python 2. But the problem with this API here is that you can use it implicitly, right? And also you can use, of course, str on things that are not iCalendar objects. So it's hard to know. You can't automatically move from this API to the new API, because you can take an iCalendar object and you can just write it to a file and it will be implicitly changed into this UTF encoded data. So there's nothing to automatically move. The new API looks like this, much better. Because of course under Python 3, str does not return binary data, it returns a Unicode string. So you can't use this API. The lessons learned here is don't use dunder methods as an API and don't use magic clever Python internals like, you know, magically inserting a meta class variable silently into a class definition. APIs should be simple, not clever. But if you end up in the bad situation that you have a clever API and you have to move it to Python 3, well then you have problems. The second thing is actually similar to the last example here, and that is the byte strings Unicode, the 8-bit strings, native strings, Unicode strings problems. And this you're gonna have to deal with most likely if you're doing any sort of strings, especially if you're doing any sort of Unicode strings. So it's hard to avoid. It can be messy. And not all of the problems here are actually anything that has much to do with Python 2 or Python 3. For example, if you are listing the directory contents of on a Linux system, it could be that you have file names that contains characters that are actually not valid in the encoding that the operating system thinks or tells Python that you should use for the file system. And then you get problems if you try to read them in and handle them as Unicode file names because you can't decode them. So you get decoding errors when you try to list a directory. So things like that, it's because Python 3 is more strict with Unicode than Python 2 is, you get problems in situations where you wouldn't get problems before. And this has to do with the fact that before, a lot of encoding, decoding between strings and Unicode would be implicit. And that works fine as long as you only use ASCII, as long as everything is just in English. But then you type in a Polish piece of string and it breaks. So Python 3 essentially trying to prevent you from doing that, so you get the error immediately and saying you can't do this. You can't implicitly change between byte strings and Unicode strings anymore. The trick for Unicode in general, also in Python 2, is to have Unicode variables separate from 8-bit variables. If you need to handle both 8-bit data and Unicode data, you should really preferably have different API functions for this. So you have different function calls. And if you can't have different function calls, then you need to, as soon as possible in that function call, check if it is Unicode or if it is 8-bit, and then change it to whatever it is you really want it to be, which is usually Unicode. It's easiest to keep all the string data as Unicode if it's text data, and then just convert it back and forth to 8-bit when you're talking to something external. Now we're halfway through the talk, which means I need to speed it up a little bit. Yes. So when preparing for this talk, I wanted to see, you know, because much of the Python 3 support that I did was done when I needed to support Python 2.5 and before Python 3.3 was out. So I wanted to check how much easier it really was. And there's also some new tools like Future, which I was going to mention. So I wanted to see how much easier it was today. So I decided to find a package, and I needed a package that was a library, so it needed to be imported from both Python 2 and Python 3, so I needed to support both. It should handle both Unicode and bytes, doing some webby stuff maybe. Some HTML handling would be good. Nobody should have tried to add Python 3 support to it before, because that would be cheating. And I should not have read the code and looked at the code. So I should not have any idea of how the code worked. Because this is the typical situation that you will be in, is that you might find that all the libraries you are using, except one, support Python 3. And the guy that maintains that doesn't seem to really maintain it anymore. So that means it's up to you to add Python 3 support to it. And you have not looked at that library before, you just use it. So that's the situation many people are in, so I wanted to put myself in that situation. And I found a library called Diazo. It's not just a library, it's also an application. It's a WSGI application as well, so you can run it as a WSGI application, or you can use it as a library. Or you can actually use it as a compiler, because Diazo takes 2 HTML pages, and I actually did a talk about this a couple of years ago on PyCon PL. It takes 2 HTML pages, and it will map bits of one page into the other page according to a rule set. And this means that you can have your designer to create your design as static HTML, and then you can map your dynamic website into that design without actually knowing how to skin that site. So that means that with Diazo you can skin PHP sites, WordPress, Plone, Django, whatever, and you don't have to learn the framework that the site is using. I've used it on pretty much any site I've been involved with for the last 4 years. It's actually a re-implementation of what another application does, and that's called Deliverance, that application. But Diazo implements this by compiling the rules into XSLT, which means that you not only can you run it as a WSGI app or as a library, you can actually take the resulting XSLT and give it to, for example, Nginx, and then you can have 200 threads doing this transformation at the same time, so it scales. So how did I go about adding Python 3 support to it? Well, first I used a tool called Can I Use Python 3? It's both a command line tool and a website. It's not entirely perfect, but it will generally tell you what libraries you need to add Python 3 support to. So in this case there was 3 libraries. The third library is Diazo itself, right? And the other 2 ones are Repose XML Eater and Experimental CSS Select. Experimental CSS Select was one of these only 2 libraries found that did not need Python 3 support. It just worked. It didn't have Python 3 support officially. Nobody had run it under Python 3. I did it. It just worked. That's very unusual. But Repose XML Eater I had to add Python 3 support to. And when I did that, I checked out its development environment, and it turned out that during development, it used another library called Collective Checkdocs. And Can I Use Python 3 didn't pick that up because it's not actually requirements, it's just a part of the development toolkit. So I could have actually dropped it, because all it does is checks that your package description renders to HTML properly, which is good to check before you upload it to the cheese shop. So it was unmaintained, so I mailed the original author, which I know him, and asked permission to take it over and added some simple tests to the module. It had no tests. And then I ran 2 to 3 on it. And it didn't work perfectly. I needed to clean up the imports manually, and I needed to add a from future import print function. But then it ran under Python 2. And then I did what you also have to do. You have to add the Python versions, the supported Python versions, into setup.py as classifiers to say that this supports Python 3. I had to clean things up a bit, added manifest in and stuff like that, and released it to cheese shop. And this in total took around 4 hours. That included a couple of false starts where I did things. I had problems that were unrelated to this, namely with TOX, which I will mention later. And it all took around 4 hours, including migrating it from an old SVN server to GitHub. Then I went on to Repose XML Eater itself. It's a wrapper to LXML, so you can iterate over it. It's not particularly exciting. But it's good for this talk because it handles both binary data and text and Unicode. text, which makes it a tricky module. So I tried 2.3 again, and it made a lot of changes, and it broke the module on both Python 2 and Python 3. And I was trying to figure out if it was the tests that had been broken or if this was the code that had been broken, and I failed. So I restarted. And I would then run the tests under Python 3 and fixed problem by problem. So each problem that didn't work under Python 3, I fixed that. And then I ran it to make sure that the problem was fixed under Python 3. And then I ran it under Python 2 to make sure that it actually still worked. So by doing this bit by bit fixing, it was actually quite easy. It gets a bit monotonous, but it wasn't very hard. But it means you have to run the tests a lot, and that brings us then to TOCs, which is a tool that will run your tests under various Python versions. It'll create a virtual env for each version, and then we'll run the test during it. But I mentioned before that I had problems with it. And it's not always reproducible. I have problems running it on a Python 3.4, and somebody mentioned yesterday, I already forgot who said so. Somebody, yeah, maybe it was Lucas that said, that if it works if you run the test under Python 2.7 first and then under 3.4 and stuff like that. But if you just run it under 3.4 directly, it will not work. Things like that. So what I ended up using instead was very simple. I just created the virtual envs manually, and then I wrote a little bash script that would run the tests for me. And this works as long as the tests are small, or you have a lot of Python versions, because otherwise it will scroll up above the top of your terminal, and then you didn't see that it failed under 2.6, for example. But otherwise it works. And this made me think, why doesn't TOCs work? What is actually so complicated about TOCs that makes it not work when a bash script works? And I ended up writing something new called Spiny, after the giant hedgehog Spiny Norman. It's in alpha state, but I released it just actually 15 minutes before this talk, the alpha. And it works, but it's absolutely not finished. For example, it still has the same problem that the error message would scroll out of your terminal. There's no summary yet if it actually worked. So this is one thing. There's lots of other little small things that needs to be fixed. If you have problems with TOCs, I invite you to try Spiny, or try it anyway and give me feedback. It's quite possible that the things that I've made in Spiny will actually then end up in TOCs in some future, because this is like an attempt to figure out why TOCs is so brittle and doesn't always work, and why it doesn't support Python 2.5, which I'm very annoyed about. Not that I need to support Python 2.5, but many modules that I maintain do in fact support Python 2.5. And that means that since I can't run the tests on the TOCs, I have to either drop the official Python 2.5 support, even though it actually works on a Python 2.5, or I will have to run it separately. And I just think it should work on a Python 2.5 too. But back to the actual issue at hand. And the issue at hand is now that Unicode problem, because we need to handle both binary data and Unicode. And the most changes I need to do was that in the tests I need to change a lot of strings to be byte strings. I need to put a little b in front of the strings, because repose XML iter will return byte strings. And the tests would not test for that. It would test just for native strings, which under Python 3 is Unicode, and then it says, oh, this is wrong. So by just putting a little b in front of all the strings in the tests, I fixed most of the issues. Most of the Unicode issues, I should say. And in the code, you also need things like this. You have to check, is this Python 3? Yes, it's Python 3. If there is Python 3, then I define something, a variable called Unicode, which is actually string. This is so that I later can check, is this Unicode? And know that it will work under both Python 2 and Python 3. And I needed to have these regexps, and I need to have one for Unicode and one for bytes. And you have, of course, exactly the same expression, but the bytes regex will not work on Unicode and vice versa. So this is the kind of code that you end up having to write if you need to support both Python 2 and Python 3, and you use Unicode. And this is also the argument why it's not backwards compatible, because you have to actually check which version of Python you're using. In total, the work to support Python 3, including the false starts that I again had here, and cleanups, and adding more tests, because it supported Unicode but didn't have test for it, was less than 6 hours. I don't know exactly. I didn't sit with a timer. Then I needed to add Python 3 support to Diazo itself. And then it's time for another tool, and it's called Futurize. And Future is a library and a compatibility layer between Python 2 and Python 3. And Futurize is a set of fixers and a script that will run these fixtures that in theory will move your code, Python 2 code, to Python 3 and keep Python 2 compatibility. It turned out, I ran this also on repos XML iter and on Diazo. It turns out that it will break Python 2 compatibility. So there's bugs in it. I should figure out exactly what those bugs are and report them, but there you go. I didn't have time, I was writing a talk. So again here what I did was running the tests and fixing them one by one. But because Diazo's code base is bigger, I didn't fix them manually, instead used Futurize to fix them. But I fixed them with one fixer at a time. So I ran Futurize. -W means write things to disk, otherwise it won't do anything. And -F for fixer and the specific fixer. -L will list the fixers, so you see which fixers are available. So for example, when I get a syntax error because there was the exception syntax has changed, I ran the fixer with the fix to change the exception syntax only. And then I ran it under Python 2 to make sure that everything worked, and then I fixed the next problem under Python 3. So it's the same thing, this iterative, boring process, fixing one problem at a time, but at this time I used the fixers in Futurize instead of changing it each case by itself. So that's a little bit faster if you have a big code base. You need to look at the code it generates. That's true for 2 to 3 and for Futurize. Futurize would, for example, put in import hooks that it then actually didn't need. So it's because it does this to be safe, because I probably will need to have these import hooks, and the import hooks means that you can import the Python 2 libraries under the Python 3 standard library names. That's what they do. But actually I didn't need that, so I removed them. Then I had to update the Diazo documentation, because I said Diazo can be run as a Whiskey app, and the documentation does this by writing ini files for paste deploy. So if you don't know what paste deploy is, it means that you can actually put together several Whiskey apps and chain them together without writing Python code. You write it as configuration is ini files instead. So I needed a Whiskey server that uses paste deploy and runs on both Python 2 and Python 3, because the Diazo documentation of course uses paste's Whiskey server, which does not run on Python 3 and never will. There is one, it's called Gearbox. I also needed 3 of the Whiskey apps that come in paste. URL map, static and proxy. URL map has a replacement with Rutter. Static and proxy has replacements in WebOb, but WebOb doesn't have the paste deploy entry point, so you can't use ini files. So I had to write a package called WebOb entry points that supply the entry points for these WebOb apps. It's pretty boring. It only supports the 2 I need at the moment. I'm going to add the other apps that exist in WebOb, so you have entry points for them. WebOb entry points took 4 to 6 hours. Most of that was me trying to remember how Whiskey works, because I haven't looked at that for many years, so I'd forgotten how it actually works. Diazo itself took around 3 hours. So total time for Diazo was 9 hours, and that means the total time for collective check docs, repose XML editor, Diazo, and web ob entry points was less than 20 hours. And much of that time was not spent porting, but figuring out what the modules did and fighting with tools like Tox and Futurize. Repose XML editor and Diazo has not been released in Python 3 compatible versions yet, but the fixes have been merged. So the next version that are released of these two are going to be Python 3 compatible. So what can we get out of this? Well, the general workflow to add Python 3 support today is to first run can I use Python 3 so you know what to move to. Make sure that you have tests and run them and fix one problem at a time. Fixing problem at a time is done by running fixers one by one until the problems you have are Unicode problems or other problems that is not fixable by fixers. If you need to support Python 2 still, which you only need to do if you if you have a library that you are maintaining that other people are using, then you need to keep supporting Python 2, otherwise you don't have to support it. If you're for your main application that you are writing, there's no point in supporting Python 2, you can just move to Python 3. So if you need to support Python 2, you use the Futurize fixers, otherwise you use the 2 to 3 fixers. And review the changes, so you make sure that it doesn't add things that's not needed. And the conclusion of all this is that Python 3 was not a mistake, and that you want to use it, and it's actually not that hard. These 20 hours, or possibly less, maybe 15, that I took here, boils down to that typically for a average third-party package, you will have to spend maybe half a day, maybe a day, to add Python 3 support for it. If it's a third-party package you've never seen before and actually just use and not looked at the code. If the code is code that you are familiar with and that you are already know how it works, then doing the porting to Python 3 or adding Python 3 support is going to be much faster. It's not really that hard, because most of these 15 to 20 hours was figuring out how a module worked, fighting with tools, wondering if it was the tests that were broken or if it was the module that was broken. But for your own code, you don't have to worry about that. So that's going to be much faster. So just do it. That's it. Or if you don't like copyrighted slogans, we can do it, maybe. Or if you don't like political slogans, you can use some other. This is your only life that you have a chance into adding Python 3 support. You know, you're never going to get to do this again. No, maybe that's not so good. But you can do it. You can dress up a King Arthur. You can move your code to Python 3. And if you don't need to support Python 2, you can use all the nice, cool features in Python 3. And it's so much nicer and cleaner and feels great. Thank you.
Hello. Why futurize and not modernize, which is far safer as refactoring is concerned, what it's doing?
Yeah, that's a good question. I just didn't have enough modules to try it out. That's the simple answer. So if I had had one more module to add Python 3 support to, I would have tried modernize, but I didn't, because everybody was talking about futurize. That's, oh, you should use futurize. Okay.
I recommend modernize because futurize is too magic.
It's too magic. Yeah, well, it has these import hooks, which are kind of pretty magic. And I didn't look at the code, so I did this mistake. I didn't actually review what futurize did to my code. So I made a pull request, and then Lawrence, who maintains Diazo, said, could we get rid of, maybe we can use the other way of doing the import hooks, because, you know, I don't know what this is going to do to Plone. And then I looked at it, I'm going, well, I don't need any import hooks. I don't actually import anything under the new names. So, yeah, I just removed it.
Oh, here.
Yep.
I wonder, once Python 2 is dead and completely on the graveyard, will there be a similar action for removing all the dirty hacks from libraries and code?
Yeah, it's a good question. Yeah, I would probably, I would expect that first of all, most of this is fairly simple to remove, and but it might be hard to remove automatically. Some of it isn't. I mean, it's like, you know, if you're using Futurize that has import hooks, then you can write the fixer to just remove the import hooks. But then again, you could probably do it with a search and replace.
I wonder if we should agree on some standard comment, for example, for marking those hacks.
Yeah, well, might be too late. But yeah, so I mean, removing the hacks are generally quite easy, so I don't think it's going to be a big problem. And it's also the same thing where you have, the code is going to have from future import things. And you can just do a search and replace it with an empty line, and you're done.
Any more questions? No, so thank you.
Thank you.